Problem E7S4 says it's possible to use crossed electric and magnetic fields to construct a velocity selector, which is a device that only passes charged particles having a certain velocity. And one way to construct it is shown in this figure here. And so we can have positive or negative particles passing through this device. So here's an example of an ion that has a certain velocity and it passes into this device. And we can see that the E field here is pointing up, and my B field here is pointing out of the page. So it's coming out at me. And so in order for this ion to come out the other side, the forces on the ion have to be balanced. So my forces due to the E field and my forces due to the B field have to equal, when I add them up, have to equal 0 in order for this ion to make it out of this little device. So if I think about that, then I know that the sum of the forces on my ion has to equal 0. And so that means that QE, that's my electric force, plus QV over C crossed with B bar, I know that has to equal 0. And the reason I used this equation, QV over C times B bar, is because of the units that they gave me in the problem. They tell me that B bar is equal to 3.0 meganewtons per coulomb. And so if you look back at page 130 in the book, you can see that you can either pick either equation, QV cross B or QV over C crossed with B bar. And so B bar has the units of newtons per coulomb as given in that little equation box. So that's why we're using B bar here. Okay, so if I think about this, when my charge, if I have a positive charge that comes in here, then Q times E, the direction of my force due to the electric field is going to be in the same direction as E. So the force on the particle due to E is going to be upwards. And now what about due to the magnetic field? If I take my hand and my fingers and I point them along the direction of the velocity, and then I bend my fingers, I'm going to have to bend them out. So I'm going to turn my hand all the way around and bend them out of the page. Then my thumb points down. So I can see that I'm going to have my E field, the force is going to be up. This is going to be F due to the E field. And I know that my force due to the B field, is going to be down. And so they can balance each other as long as I set them to 0 and then solve. So I'm solving for E. So I have I can subtract QV over C cross B from both sides. I subtract it from this side. That's a B bar there. Okay, so this cancels. And I find that QE is equal to a negative QV over C crossed with B. Okay, and so again, let's define my direction here. So I'm going to have, this is my X direction and this is my Y direction. Okay, so now I can also cross out my Q's. And so I find that E is equal to a negative V over C B bar. And the reason I can just write V times B bar is because the velocity is in the X direction and my B bar is in the Z direction. So I know that V crossed with B, the X direction and the Z direction are 90 degrees apart. So I know that sine of 90 is equal to 1. So V cross with B, so V cross B is equal to VB sine theta. And so I just have this is equal to V times B. And these should be B bar. Okay, so now I can plug in my numbers and I have E is equal to a negative 0.01 C over C, and B bar is 3.0 times 10 to the 6th newtons per coulomb. My C's cancel, and I find that E is equal to a negative 3.0 times 10 to the 4th newtons per coulomb. So my units check out, and I find that E is in the opposite direction as B. So this B here, right, is in the negative direction. So this B is in the negative y direction, so I should have a negative here. So I should have a negative here. And so that means I have a positive here because the two negatives cancel out. So I end up with E in the positive direction, and that's how I define my coordinates early on. Right up there. So we can see that E is equal to 3 times 10 to the 4th newtons per coulomb.